Hey there, I'm Ken. This is Canadian Retro Things. Welcome. It's time to work on this CRT monitor. If you've been following my videos about getting my TRS-80 Model 1 working, you know that I do have a complete system. I have the computer, the expansion pack, the disk drives, and, well, right here, the monitor. I've gotten everything on that computer working so far except, well, the monitor. So that's what we're working on today. Now, a complete disclaimer. Monitors are full of some high voltages, and if you are at all worried about working on these, then I suggest don't do it. Find somebody that actually can show you how to do it, or that will do it for you. But if I'm correct about what's wrong with this monitor, then I shouldn't actually have to go anywhere near all the high voltage stuff. If I do, I'm going to, of course, be doing it very carefully. All right, so, yeah, I guess we've got to take this monitor apart and test my theory about what's wrong with it. But before we do that, I have to give a big thank you to the sponsor of today's video, PCBWay. PCBWay, where you can have PCBs printed starting at only $5 for 10 boards. One of the reasons you should choose PCBWay is the technology they use to produce printed circuit boards for you. They're at the forefront of technology, providing you with the best possible solutions. Their manufacturing facilities are equipped with advanced machinery and tools that enable them to produce PCBs with exceptional precision and reliability. All of this is used in a 20-step process, bringing your PCBs to life and delivering them quickly. So why not visit PCBWay today at www.pcbway.com and PCB prototype the easy way. So here we are with our monitor ready to be taken apart. As you can see, this is one of the old original monitors from the TRS-80 Model 1, manufactured July 1978. Made in Taiwan, serial number 830555162, model KTR123S. Now, we did see in the past how we're getting this picture from the monitor, which is a good sign. That means that in all likelihood, the monitor itself is working. It's turning on, there's contrast. What's not working is the video input, which means there is a separate little video input board inside of here. We're hoping that the problem is with that. So I started taking the screws out, and I think there's a good possibility that this has been worked on before. I mean, you can correct me if I'm wrong, but I don't know if you can see them here, but these are self-tapping screws, and I don't think this monitor was probably originally supplied with self-tapping screws. But there's 5 of them, there, and there, to take out there. So let's continue doing that, and then we'll pop this back off and see what we can see inside. All right, there we go. Basically, it's an RCA TV with this little board added on right there to make it able to read the signal from the computer. And of course, these are a little bit famous for having no cup on the connector to the tube there, so we're going to stay away from that side of things. Right now, we're just going to be working on this. We're probably going to throw a little bit of deoxit into the knobs back here while we have this open. But otherwise, this is, in fact, the board that we want to look at. So let's see if we can get this out. All right, well, I'm going to take some look at this and see if there's anything I can see wrong with it. and look at the connectors and everything else. The first thing I want to check on this board is I have it hooked up to the computer, so give it some power. Give it some power. So the first thing I want to check on this board is, got it hooked up to the computer over here, so turn that on. And now we can check to see if there's 5 volts going into pin 2 of that chip. Huh. Significantly less than 5 volts. Let me just check what's coming from the computer itself. Odd, that's only getting 3.2 volts, so that very well could be our problem. Why are we only getting 3.2 volts? All right. So now, I guess it's time to check and see what the output from the computer is. So, into the ground pin and into the 5-volt pin. Okay, well, we are getting actually 4.94 volts out at the computer, which means it's not the computer that's the problem. It sounds to me like it might be the cable that connects the computer there. Okay, well, I guess I got to take a little bit more apart. I think I'll desolder that cable from the board, and then I can do some testing on it. I have the board out, and it's time to check this. Now, I've discovered something. I've discovered that I am a complete moron because there we go. We're 4.5 volts. That's not perfect, but it's a lot closer than it was before. Now, why, you may ask, is that? Well, let me show you. I messed up on the board right here. See, I was reading that is the power, which it is. That's the power line, and I was reading that as the ground. Now, I just assumed that's the ground because of the big solder point, right? Like the big solder line here. See, on this side, this whole big thing, that's all ground. On this side, it's not. That's the signal in. This is the ground right here, this little tiny guy. So on this side, the ground plane is the huge part, and on this side, the ground plane is tiny little. Which, yeah, that confused me. I'm not used to seeing that. I'm used to seeing the large solder line area being the ground. So, oops. So I've looked this board over quite thoroughly, and I'm going to do some testing on it, but everything looks absolutely fine. The capacitors are not in any way bulged or anything, no broken traces or anything like that. The optical isolator may be the problem. These are relatively touchy chips that if you get any kind of a voltage spike on them, it can fry them. So I can hear you saying it's all good and everything, that I am guessing the optical isolator is bad, but how am I going to know that without just replacing it? Well, here we have the schematic of the chip. So as you can see, it's basically made up of 2 diodes and a transistor. So I'm going to just do a quick and dirty test with my multimeter here. As you can see, one of the diodes is connecting pin 2 and 3. Well, if you put the positive on pin 2 and the negative on pin 3 of the multimeter, you should get a resistance value. If you switch that around to the negative on pin 2 and the positive on pin 3, the diode should prevent it from reading anything. It should be a big fat 0. And the same should follow suit for pins 7 and 8. If 7 is positive and 8 is negative, you should get a resistance value. If 8 is negative and 7 is positive, you should get a 0. So let's go quickly test that out and see what's going on. And here we go. Okay, so this up here is pin 1. So first thing we will do is positive on pin 2, negative on pin 3, and we are getting a value. As you can see, I am currently set here on my diode tester. Let's switch that around. Negative and positive. And we're getting nothing. So the diode on that side works. Now, pins 7 and 8. So 8 should be the negative, and 7 should be the positive. So we're getting a resistance value. Switch that around. And we're getting nothing. Okay, so maybe that chip is not bad. Everything seems to be acting like it should. Time to test some other components. I've hooked the board back up to the computer so that I can properly test things now. So we've got our ground and our positive 5. And now we're at 4.1 volts. Okay, so it's very, very odd that coming out of the computer, we've got just under 5 volts. With the bare wires, we've got about 4.5 volts. Hooked up to the board, we've got 4.1 volts. So things are just steadily dropping. I'm going to guess that, well, first off, the cable may be impeding things a little bit, but I think also, like, that's a 20% drop in voltage almost, and that's just not good. So I've got a few test points here that I can do to try and figure out if things are working or not. Now, this is the ground here at the top of R1. And we're first going to test the middle pin on Q3, which should be 2.5 volts about. And we're a little high on that, 2.6, so that's nothing bad there. The next one is where R2 goes into R7. Should be about 1.8 and at 1.85 volts, 1.93, so we're a little bit high there too. And where Q3 goes into R9. Okay, and we should be 1.76 and we're 1.87, so also a little bit high. Now, pin 2 on Z1 should be 4.99 volts. And we're 4.11. And pin 3 should be 3.49 volts. And we're 2.61 volts. So, seems like things going around on the board are actually a little bit high, but within specs. It's by the time it gets to the chip Z1, and actually the initial amount coming into the board is wrong. So my question would be, is there a component somewhere on here that is dragging the voltage down? I'm going to guess there is. So I'm going to do a little more research. Looking at the schematic, I can see that R8, C3, and C4 are all directly connected to the 5-volt line. So, if any of those are dragging the power down, I would guess maybe C3. So I'm going to start by taking C3 out of there, testing it. I'm going to test that circuit without it in there to see if that makes a difference or not. Alright, C3 is out, and I've got it in my tester here. It's a 10 microfarads, so it's testing at 14.81 microfarads, which is almost 50% higher than it should. Interesting. Alright, I'm going to now just test this circuit without that part in there and see if there's any change in the voltage. Alright, we have the board ready to test, so let's just see where we're at with the voltage. Now we're only at 4.08 volts and 2.58 volts, so we're almost an entire volt down. Let's just check it right at the source. Yep, 4.08 volts. So taking that out has caused it to be dragged down even further. Well, there's only two more components connected to the 5-volt line. That, of course, is resistor 8 and capacitor 4. So let's take off C4, and then we'll test it again. And that capacitor is now out. It's in the tester. It should be about 10 nanofarads. 11.4 nanofarads. So that one looks like it's good. So I'm going to guess it's not the problem. So I'm just going to, rather than moving everything and hooking it all back up again, I am just going to take out that resistor and see if we can test that. And maybe that's the problem. And the resistor is out. It's in the tester. It should be a 2000 ohm resistor. 1991 ohms. All right, so nothing wrong with that resistor either. There has to be a different component on here that is dragging the power down. All right, I have gone through and I have checked every single part on this side of the board. And I've replaced just two parts that weren't working. And we are still getting just over 4 volts. So well under what we should be getting. 4.02. Now, because this side of the board is, in essence, completely isolated from this side of the board, nothing on this side of the board should be affecting over here. So the only thing is the chip. So I will pull that chip out now and check to see what the voltages I get then are. And here we are, the chip is out. So now, let's see what our voltage is. 4.42. So that is much closer to what's coming out of that wire. I mean, that's not the right voltage. That's not what should be coming out of here. It should be about 4.99 volts. But it looks like my initial thought was right. It is that chip. So I guess I have to order another one. Well, that was a bit of a roller coaster ride. I guess I should have stuck with my initial assumption about the chip being bad. Of course, if I had done that, I wouldn't have found that the capacitors were also bad. And of course, I am going to check the rest of the capacitors on that board just to make sure that they're working. But yeah, with the chip, I did that quick and dirty method of checking to see if it works. And it was doing all of the things it's supposed to. It's just that it's not quite working properly. It's somehow putting a voltage drain on the board, so that's not good. Also, the other problem, of course, is that cable. I'm assuming somewhere along the line in that cable there's a crack or something in the wiring somewhere that's causing a bit of a voltage leak, so that's going to have to be changed. But for now, a new chip has been ordered, and yeah, I just have to wait for that to come in, and then I can hopefully get this monitor working, and that will mean that my TRS-80 Model 1 is 100% working. But for now, that's all I can do, so I hope you enjoyed this video. If you did, don't forget to do all of that YouTube-y stuff, like, thumbs up, commenting, everything like that, because they're all appreciated, and they all really do help the channel out a lot. Anyways, for now, that's everything, and I will see you later.